Okay guys, today we'll be doing 3.2, definition of a derivative, or another way to say derivative is slope of a tangent line, or instantaneous rate of change. Let's get started. Okay, first thing, I'm just going to explain to you how they came up with a derivative. Estimate, using an example from that you guys should know how to do from 3.1. Estimate the slope of a tangent line at x equals 2 using the slope of a secant line of the function. Okay, this is our function f of x. So what you should be doing when you see this estimate a tangent line, the slope of a tangent line, that is the keywords to use f of b minus f of a all over b minus a. Okay, and we're doing it at x equals 2, which means we have our a value, which goes right here, and we just need to come up with a b value that's very close, so we're estimating the tangent line. So a value that's very close, you could do like 2.1, or you could do something closer, 2.01, anything you want. So what we're doing is f of 2.1 minus f of 2 all over 2.1 minus 2. Now if you plug in 2.1 into here, you get a okay, that would be 4.2 plus 5 would be 9.2. Minus, if you plug in 2, so now plug in 2, 2 times 2 is 4, plus 5 is 9, all divided by 2.1 minus 2 is 0.1, and that is going to be 9.2 minus 9 is 0.2 divided by 0.1, which is 2. Okay, so our answer to the estimation of the tangent line at 2 is 2. And this one is an easy one because you guys know what this looks like graphed. Okay, so let's just graph this real quick. Okay, what it looks like is we know our y-intercept is 5, and we know our slope is 2. So we have a point right there at 5, and then we know it goes up 2 and goes over 1, has another dot, and then you connect all these dots, and it has a slope equal to 2. So what I was asking you for is what is the slope at 2? Well, the slope everywhere is 2. So you knew the answer to this before you even did this. You should have anyways. Where this starts getting more difficult is when you have a graph that has a constant changing slope, maybe like a parabola. If you look at this, there is no slope that is the same throughout the entire graph. If you grabbed right here, your slope would be positive. Yeah, if you grabbed over here, your slope is going to be negative. Just there's an infinite amount of slopes on a parabola, just like you would think about on like a cubic function. The slope is always changing. So what Isaac Newton asked himself is, I can find an instantaneous slope here, because since the slope's always 2, I want to be able to find the slope at any point on a graph like this, or any other graph. So how am I going to do that? What Isaac Newton did was he looked at this thing right here that we were using to find the average rate of change, or to estimate the tangent line. And he said, well, let's advance upon this. Let's say we're starting with here. What we're doing is we're trying to find it at 2. What we did was we added some very small amount to the value of 2. Let's call that small amount h. We subtracted off that original amount, f of 2, and we divided by, if you notice, when you subtract it on bottom, you end up with that small amount that we had added. So we divide by h, that small amount. And what we're trying to do is we're trying to get a value that's really close to 0 when our h is close to 0. And we just spent an entire chapter doing limits. So we can do this, a limit as h approaches 0, and that would make this small amount on here very, very tiny. It'd make it much smaller than 0.1. It'd be infinitely small because we're doing a limit, what it's approaching as it goes to 0. Now, if you notice right now, it's doing this value at 2. Let's say I want to figure it out at any value. I don't have to use 2, I could just use x. And then I can find the slope at any value I want. And that right here, that's the definition of a derivative, which I have on the next slide here. I'll give you a second to copy it down. Okay, so this is the definition of a derivative. And so you have it verbally as well. A derivative is the slope of a tangent line, or the instantaneous velocity, or another way to think about it is instantaneous rate of change at any point that you want. You can find the slope anywhere you want. That's what this thing can do for you. Okay, so let's show you how to use it. First off, let's show you how to say it. So there's multiple ways to say derivative. You could say f prime of x. That's one way to say the slope at any point. Dy over dx is another way to say the slope at any point, or y prime. And then verbally, you can say instantaneous rate of change, instantaneous velocity or acceleration, depending on what you're talking about. Or you can say the slope of a tangent line. Yes, slope of a tangent line. So you got various ways to say derivative. Yeah, right here there's 5 plus just the word derivative. We got 6 different ways already. Okay, let's show you how to do one of these. Okay, this is one where it's very easy. Okay, it's asking find the slope at any point. Well, you should already know the slope of this thing. The slope is right here. It's in the mx plus b form. So your answer should be 3. So what we're going to do is we're going to use our long equation here to prove it. The limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, we're going to do this the long way to hopefully get the answer of 3. Okay, we're going to have the limit as h approaches 0 of 3. Now, this portion right here I'm going to do in brackets. It's x plus h. It's the function, and wherever there's an x, we're just going to plug in x plus h. So we have 3x plus h plus 2. Now I'll put that in brackets so you can see that is that first thing right there. And then minus, I'll put this portion in parentheses. F of x, well the function is f of x, so 3x plus 2. There you go, all divided by h. Okay, well, let's keep working this out. Now remember, what I want to do on a limit to any number is I want to plug it in and get the answer. Well, if you plug in 0 here, you end up with a 0 on the denominator, which is undefined. And so you go to the second step, which is manipulating the problem to try to make it so you can plug in 0. So let's manipulate this problem. The way I'm going to manipulate it is distribute this 3 into both of those, distribute this negative into both of these. Okay, so we're going to have 3x plus 3h plus 2 minus 3x minus 2 all divided by h. Now remember, I still have the limit as h approaches 0 on the front here. Okay, now if you're doing this right, these things at the end should all cancel out. Look at this. You have a 3x and a negative 3x. You have a plus 2 and a negative 2. And you're left with the limit as h approaches 0. All you're left with on top there is 3h over h. But you still can't plug in 0. You can cancel these h's out, leaving you with the limit as h approaches 0 of 3. And now you can plug in 0, but there's nothing to plug it into, so your answer is just 3. That means your slope is just always 3, which we knew at the beginning, right? We knew our slope was going to be 3. So at this point, I could ask you, like, find the derivative, find the slope at, I don't know, 5. Well, I know the slope everywhere is 3, so the slope at 5 is 3. I could say find the slope at 100. Well, the slope everywhere is 3. Yeah? Now, if this wasn't, like this graph is always has a slope of 3, but let's say it looked like something like a parabola, your slope isn't going to be 3 everywhere. You're going to have different slopes everywhere on this graph. So let's do one that's different. Okay. Okay, find the instantaneous rate of change of the function g of x of this function 3 over x. Okay, so we're going to be doing that same thing because it says find the instantaneous rate of change. That means the limit as h approaches 0 of f of x plus h minus f of x all over h. And I will do that same form of organization where I will put brackets around this portion and a parentheses around this portion. Okay, so let's start up here. The limit as h approaches 0 of 3 over, now remember this is the x plus h one, so wherever there's an x I'm putting x plus h, and that's that beginning portion there in brackets, minus f of x, which is just the function, all divided by h. Okay, what you should notice here is I can't plug in 0, so I got to go to the next step. I got to manipulate this numerator here. Well, I want to combine these two terms, and I can't do that unless I have a common denominator. So I'll multiply this side by x over x. And I'll multiply this side by x plus h over x plus h. That will help me get a common denominator. So we're going to have the limit as h approaches 0. And then over here, 3 times x is going to be 3x over x, I mean, you can write this out if you want to, x squared plus xh. That's me distributing that x into both of these things, okay? That is this whole first portion minus this second one. So I'll distribute that 3, and it's actually, what I'm distributing is I'm just distributing this negative 3 into both of them. So it's going to be a minus, let's do minus, I'm going to plus, it's going to be negative 3x minus 3h. That's me distributing that negative 3. You could have left it as a negative on the front, but then you would have had to distribute the negative after you wrote it out. There's just different ways of writing it. Okay, plus xh. That's me distributing that x into both of those as well. Okay, that gave us a common denominator. So now we can combine our numerators here. I mean, yeah, our numerator. Okay, so that's going to leave me with 3x plus a negative 3x. Well, that should cancel those out, leaving me with just a negative 3h on top over x squared plus xh over h. Well, I want to combine this, so I have one fraction, so I need to put h over 1 and do the sandwich method. So this times this will be my new numerator, that times that will be my new denominator. So we'll have the limit as h approaches 0 of a negative 3h over, and I am going to leave the h not distributed, and you're about to see why, x squared plus xh. Now the reason why I did not distribute that h is because, look at that, the h's are going to cancel. So that'll make it easier to deal with. Okay, now we got the limit as h approaches 0 of a negative 3 over x squared plus xh. And now I can plug in this 0, and I don't get a 0 in the denominator. So look what I get. Negative 3 over x squared plus x times 0. Well, x times 0, this whole term cancels out then, and you're just left with negative 3 over x squared. And this right here is an equation. Okay, it's an equation to find the slope anywhere. Okay, now notice this graph wasn't like the other one. This graph has a constantly changing slope. Okay, it's going to look something similar to this. Yeah, it's kind of hard to draw on here, but it's going to look, the graph is going to look something like that. The slope is always changing. So we now have a equation to find the slope anywhere we want on here. So like, let's say they asked, well, find g prime of, I don't know, 1. That means find the slope, that prime means slope, find the slope at 1. Well, I have an equation to find the slope anywhere now. So negative 3 over 1 squared. Well, that would be -3. The slope at 1 is -3. I mean, they can ask you any point they want now. Find the slope at 5. Well, let's see here. So it'd be -3 over 5 squared. So it'd be -3 over 25. And that doesn't simplify, so that's my answer. The slope at 5. It'll find you the slope anywhere you want. That's the whole point of a derivative. Okay. Now we'll do one more. I just want to do one more because the mathematics might be difficult for you all to find out by yourselves. Okay, so this one's telling you to find the slope, find the derivative of this. You're gonna have, so that's telling you, well, I got to do the limit as h approaches 0 of f of x plus h minus f of x all over h. I'll do the same form of organization. I'll do brackets there, parentheses here. Okay, so this one's going to take probably the entire screen. So remember the first one, the brackets. Wherever there's an x, I'm plugging in x plus h in both of these. So I'm going to have 2x plus h squared plus x plus h minus 5. Okay, that's the end of the bracketed one. That's the f of x plus h minus f of x, just this original equation, 2x squared plus x minus 5, all divided by h. Okay, so obviously we can't plug in 0 because you divide by 0, so we need to manipulate this thing. This is where the long work is going to come into hand. It's not very difficult work, it just takes a while. Okay, first thing is this x plus h squared, that's the same thing as x plus h times x plus h. That's what that means. So why don't we do this on the side real quick. X plus h times x plus h. That's going to give us x squared plus xh plus xh plus h squared. And these two things can combine, leaving us with x squared plus 2xh plus h squared. Okay, so that right there is what this is equal to. So I'm going to rewrite that in there. So brackets 2, and then this is my replacing this right here. So x squared plus 2xh plus h squared plus, I'll distribute this positive, which doesn't change anything, x plus h minus 5. That's that whole bracketed area. And then I'll just distribute this negative into all these things right here. So negative 2x squared minus x plus 5 all over h. Okay, notice I still can't plug in the 0 for h yet. So let me distribute this too. And after you do this, you should start seeing a lot of things canceling out. So we're going to have 2x squared plus 4xh plus 2h squared plus x plus h minus 5 minus 2x squared minus x plus 5. Notice I just got rid of the brackets because I had finished distributing everything in that first portion here. Okay, so here's where stuff should cancel out. 2x squared cancels out with a negative 2x squared. Plus x cancels out with a negative x. Negative 5 cancels out with that. Okay, and we're left with the limit as h approaches 0 of, on top we got 4xh plus 2h squared plus h all over h. Okay, if you notice, every single term here has an h, so we can factor an h out. So we have the limit as h approaches 0 of h, which is now going to be 4x plus 2h plus 1 all divided by h. Canceling out those h's, meaning now we can do the whole thing we've been wanting to do, which is plug in 0 into h. So 4x plus 2h plus 1. Okay, now we can plug in 0, leaving us with 4x. This cancels when you plug in 0, plus 1. And that's an equation to find the slope anywhere. So like, let's say they say find y prime of, I don't know, 5. They want to know what the slope is at 5. Well, 4 times 5 plus 1, that would leave us with 21. That's the slope of this graph at 5. And you can do it at any point you want now. So that is the way to find a derivative. You've got to follow this equation, and notice there's some functions that are going to be very difficult to do this with. So in the future, we'll be talking about some shortcuts, some ways to do this that will make this whole process shorter. Okay, so a derivative gives you the equation to find the slope of a line at any point. That is a one-word, quick way of thinking of a derivative. Derivative means slope.